Today we're going to be talking about exponents and how we use them. So first let's go over a couple definitions. A base, the formal definition, is the number used as a factor. For example, if I were to look at the expression 3 to the 7th power, my base is 3. So it's always the big number. If it helps you, base starts with a B, so does big. So the big number is the base. So in this case, it would be 3. Now the exponent is the other number. So the exponent shows the number of times the base is used as a factor. So it shows the number of times the base is used as a factor. And we'll use that same example, 3 to the 7th, and this example 7 would be the exponent, so it's the little number. So those are our definitions. Now we're going to look at an example. Now you don't have to write down this whole thing, but just kind of follow along. So it says, suppose there's a snow day in November. That would be nice. The staff of New Haven High School has a fan-out list to make sure everyone knows about the snow day. First, Mr. Timmerman calls 2 staff members, and we call that step 1. And then each of those staff members calls 2 other staff members, and this continues until all staff members have been called. How many members are called on step 3? So let's draw a little diagram to help us figure this out. So it starts with Mr. Timmerman. And then he calls, and this is step 1. So he calls, we'll call them people A and B. So this is like step 1. He calls 2 people, then each of those people call another 2 people. So we'll say person A calls person C and D, then person B calls E and F. Oops, I forgot to write. This is step 1. So this second step, this second round of calls, would be step 2. And we want to know how many members are called on step 3. So each of these people are going to call another 2 people. So F, G, H, I, J, K, L, M, N. So each of those people calls another 2. That is our step 3. And if you count up the number of people that are called, you get 1, 2, 3, 4, 5, 6, 7, 8 people. So that's how many people are called. And then if we want to relate this to exponents, well, we started with 2 people. Then each of those 2 people called another 2 people. And then another 2 people were each called. So this is actually, this can be represented by 2 times 2 times 2. Which is 8. So this is kind of going to lead us into some more exponent rules here. So here is this chart. You can copy this down. We're going to go over how to write different exponents, how to read them or say them, and then how to evaluate them. So first one we'll say is 14 to the 0 power. That's how you say it. So it's raised to, it kind of looks like a degree symbol, but in this case it's a power. So the way I would say this is 14 to the 0 power. It's important to use the right phrases when you're talking about exponents. And actually, if I were to evaluate this, anything to the 0 power gives me 1. If I had 1,000,000 to the 0 power, it would still be 1. Okay, next we'll do 12 to the 1st power. So if I have a little 1 there, that's to the 1st power. 12 to the 1st power. And 12 to the 1st power is just 12. Anything to the 1st power is just whatever your base is. So if I had 20 to the 1st power, to evaluate that it would be 20. Next one I'll say is 5 to the 2nd power. So I could say this is 5 to the 2nd power. Or another way to say it is 5 squared. Actually, you'll more commonly hear it as 5 squared, but they both mean the same thing. So 5 squared means I'm going to multiply 5 with itself twice. So 5 squared is not 5 times 2, it's actually 5 times 5, which has a value of 25. Next one we'll do is 6 to the third power. So when I have a power of 3, it can be said as either 6 to the third power, or another way to say this is 6 cubed. So to the second power is squared, to the third power is cubed. This is, again, the more common way to say it, but they both mean the same thing. So to evaluate 6 to the third power, I'm going to multiply 6 with itself 3 times. 6 times 6 times 6. Now don't confuse this with 6 times 3. Our answer is not 18. It is actually, so 6 times 6 gives us 36, and then multiply that by 6 again, and we get 216. So that's how we would evaluate 6 to the third power. Let's mix it up a little bit. What if I had negative 2 to the fourth power? This actually means the opposite. The way I would say it is the opposite of 2 to the fourth. So whatever 2 to the fourth is, I'm going to take the opposite. So the way I would evaluate it is, well, I want to find 2 to the fourth, which means 2 times 2 times 2 times 2, multiply 2 with itself 4 times. And then once I do that, I'm going to take the opposite. So 2, we'll ignore the negative sign for now. Figure out what, so 2 times 2 is 2 times 2 is 4, times 2 is 8, times 2 again, we get 16. But then I would take the opposite of that. So this is actually going to give me a negative 16 when I evaluate it. Now, let's just make a little note to ourselves here. The opposite of 2 to the fourth is not the same as negative 2 to the fourth. Sometimes people misread this. I think I might have even said it earlier on accident as negative 2 to the fourth. This is actually the opposite of 2 to the fourth. This is negative 2 to the fourth. Now the difference is negative 2, or the opposite of 2 to the fourth, gives us a value of negative 16, just like we found in the chart. Because we find 2 to the fourth and then we take the opposite. Whereas negative 2 to the fourth power actually means do negative 2 times negative 2 times negative 2 times negative 2. And when I multiply 4 negative numbers together, that's an even amount of negative numbers. So that results in a positive 16. So notice how I got different answers for these two expressions. So again, this is not negative 2 to the fourth. This is the opposite of 2 to the fourth. Okay. And we're going to move on to example 2. I'm going to practice writing some expressions using exponents. So the first one is 8 times 8 times 8. So that's 8 multiplied with itself 3 times. So the way I would write this is simply 8 to the third power. Next one is negative 7 times negative 7 times negative 7. So that's kind of similar to the example we went over earlier. This one here, negative 2 to the fourth power was negative 2 times negative 2 times 7. So this is similar, only with 7s. So this is equal to negative 7 to the third power, since there's 3 of them being multiplied together. Again, that's not the same as the opposite of 7 to the third power, or cubed. Okay, these two things are different. Go back and look under the chart if you need a refresher on that. Okay, I'm going to do part C now. So I want to write this using exponents. Well, I've got a variety of terms here. I've got 3 times x times y times 2 times y. So I'm going to first multiply the numbers together, because I know 3 times 2 is just 6. Actually, you know what? I'm going to rearrange these first. I'm going to put the numbers together, And then I'm going to put the x, and I'll put the y's next to each other, just so we can kind of more easily see it. I just rearranged things. I used the commutative property of multiplication there. And then 3 times 2 is 6. X is just x. Y times y multiplied with itself 2 times, is y squared. I'm going to write that as y squared. And they're right next to each other, so that just means that's multiplication. So I just condensed that, and I wrote it using exponents. Okay, here I have 0.4 times 0.4 times x. So 0.4 is multiplied with itself 2 times, so I'm going to write that as 0.4 squared. You don't necessarily need the parentheses there, but you can put them when there's decimals. There are decimals. And x, there's only one x, so I'm just going to write 0.4 squared times x. If there were more than one x, I might have to put, if it was x times x, I would put x squared, or x to the second power. So that's my answer there. Okay, next I'm going to look at evaluating powers with variables. So this says evaluate the expression x to the 4th when x equals 3. Okay, so evaluate means come up with a value or a number. So I know x is 3, and I want to find x to the 4th. So x to the 4th, well, if x is 3, I'm going to substitute a 3 in for that x. I get 3 to the 4th. And 3 to the 4th means not 3 times 4, it's not 12. This means multiply 3 with itself 4 times. So 3 times 3 times 3 times 3. And you could, go one by one, or you could actually, a simpler method. I know 3 times 3 is 9, and I know this 3 times 3 is also 9. So if I multiply the two 9s together, since this is all just multiplication, 9 times 9 gives me 81. So that would be my answer. Okay, so there's an evaluating example. I just substitute my values. Okay, we're going to do a few more here. So next we're going to use area and volume formulas. So this one says the area A of a square uses this formula. A equals S squared, where S is the length of the sides. So actually this is just a reference. So area is always measured in square units, if you want to add that into your notes. Area is measured in square units. So if I were to find the area of something, maybe I measured it in feet, my unit for the area would be feet squared. Now volume is, so the volume of a cube is found by taking the length of a side and cubing it. Kind of makes sense. It's called a cube. So s to the 3rd power, s cubed, is going to give you the volume of a cube. So this is measured in cubic units, such as feet cubed. So if I were to try to find the volume of this cube and I measured each of the sides in feet, once I find the volume and do, s times s times s, I would label it with feet cubed. That's my unit for volume. Okay, so with that in mind, we're going to do example 4. It says you're planning on putting wall-to-wall carpeting in your room. To do this, you need to find the area of the square-shaped floor. Okay, so I'm given this square, and I need to find the area of it. So to find the area, we go up to our formula here. It's just simply the length of a side, squared. So the area equals s squared. In this case, my s is 11 feet. So I'm going to substitute 11 in for s. 11 squared. 11 squared means not 11 times 2. It's 11 times 11, which is going to give me 121 feet. And remember we said when we're measuring area, our units are always squared. So it's going to be feet squared for my answer. And I'm done.